Here we have a two-dimension motion problem that says Mary is 5.37 meters away from Greg when she throws a pumpkin at him at a speed of 16.32 meters per second and at an angle of 18.97 degrees. At what speed does the pumpkin hit Greg? So it's always a good idea to start with a diagram. So here we have 5.37 meters. Velocity of 16.32 meters per second and an angle of 18.97 degrees. Now, since this is a two-dimension problem, it also helps to fill out a T-chart with horizontal and vertical values. So we know that the horizontal displacement is 5.37 meters. We know that the horizontal acceleration is 0 meters per second squared, and the vertical acceleration is negative 9.8 meters per second squared. And for the initial and final velocity, we don't know either of these or the time. So first we're going to find the initial velocities. So with the hypotenuse being 16.32 meters per second, we can use cosine and sine to find the other sides. So to find the horizontal initial velocity, that would be this side, so we need adjacent over hypotenuse. So that would be cosine of 18.97 equals adjacent over hypotenuse. So we can multiply that to get in the front and get adjacent by itself. Now we put that into the calculator and we get that the adjacent side is equal to 15.48 meters per second. So now we could also fill that in here. We now know that the horizontal side is 15.48 meters per second. Now to find the vertical one, we do the same thing except with sine. So sine would be opposite over hypotenuse. And we could do the same thing as last time. So then we can do the same thing to isolate the opposite side by multiplying the 16.32 into the front. So now we do the same thing as before. We put that into the calculator. And we get that the opposite side is equal to 5.32 meters per second. So now we can put that into the vertical initial velocity. And now we can find time by using the horizontal values in the displacement equation, which is x equals initial velocity times time plus 1/2 of the acceleration times time squared. But since horizontal acceleration is 0, that cancels all of this out, and all we have left is x equals vi times t. And since we're trying to solve for t, we could isolate it by dividing by the initial velocity, giving us x divided by vi equals t. So now, using unit analysis, we could do 5.37 meters divided by the initial velocity the meters cancel out, and we divide these in our calculator. just left with 0.35 seconds. We could also put that in here. Now all we have left to find are the final velocities, but since the acceleration for horizontal is 0, we know that the final velocity of it is going to be the same as the initial velocity. But to find the final velocity of vertical, we can use the acceleration equation. I'm just going to clear some space here. And we know that the acceleration equation is A equals VF minus VI over t. Since we're trying to solve for the final velocity, we can multiply t onto this side to get at, and then add the initial velocity onto the other side to set it all equal to the final velocity. Meters per second squared times the time, which is 0.35 seconds. These cancel out. And then we have adding the initial velocity, which we know is 5.32 meters per second. And so now all that's left is negative 9.8 times 0.35, which is negative 3.43 plus 5.32. They both have meters per second left, and that gets us the final velocity is 1.89 meters per second. We can put that up here to fill in our chart. And now that we have both of these values, we can make another triangle using those values. So now I'm going to clear some more space again over here. So now we can draw another triangle. And we can take the horizontal final velocity take the vertical final velocity and now we know that Pythagorean theorem is a squared plus b squared equals c squared. So we take 1.89 squared plus 15.49 squared equals c squared. So 1.89 squared is 3.57. 15.49 squared is 239.94. Now we add these together and we get that 243.51 equals c squared. Now we take the square root of that and we get that c equals 15.6 meters per second. And that is our total final velocity of the pumpkin.